So welcome guys in Cyber Pathshala, and in control system series we are going to start with block diagram, some basics of block diagram, and later on video I will cover the numerical part, and then we start the single flow graph. So let's start with the block diagram reduction techniques. So first of all, as you know, this is a summer and it is a multi input and single output summer. Okay, so the output is y is equals to x plus x1 minus x2. As you can see that in x2 there is a minus, that's why. And this is the multi input and multi output summer. So basically as its name denotes summer, so you can see it's working. Okay, now moving to the takeoff point. Application of one input source to or more system is represented by takeoff point. It means that only one input and multiple outputs denoted by takeoff point. Okay, so moving towards the forward gain. Forward gain or G, transfer function. Basically transfer function is the ratio of output upon input, and as you can see that output is y and input is x, and the gain is g. So output is equals to gx, and as you transfer the x you will get the transfer function y upon x, that is g. So moving to the next slide. Wait a minute. So here are some basics of how to reduce a block diagram. So in case 1, to move the summation point on the other side of the gain in the direction of flow. As you can see that it is the direction of flow. So in the direction, if you want to move a gain before the summer, so as you can see that you are having a g multiplying with x1 plus x. So when you move this summer in the direction of flow, so you have to multiply with gain g. As you are not getting g before this, so you have to multiply when you move summer in the direction of block diagram or in the direction of gain flow. To move the summation point on the other side of the gain, the direction of flow of the gain term g will be introduced as its second input. Okay, so the case second. To move the summation point on the other side of the gain opposite to the direction of flow, as you can see that in the we are moving the summer in the direction of the opposite in the direction of flow. So you have to divide the gain by you have to divide the gain. Moving to the next case, the case third. Here the case third is that to move a takeoff point on the other side of the gain opposite to the direction of flow. Here the gain G1 is moving opposite to the direction of flow. So as you can see that here you are getting gain G with G1, and if you move it in the opposite in the direction of flow, you didn't get the gain G, so you have to multiply it with the gain G, so that we can compensate it. Okay, so here it is written that to move a takeoff point on the other side of the gain opposite to the direction of flow, the gain term g will be introduced at its second of takeoff point. Here are some key factors. If you have two summers consecutively, so you can interchange the two summers. Okay, so moving to the third slide. Okay. here you can see that there are multiple inputs and one output. So you to reduce a block diagram or to simplify the block diagram, you can take two summers. So this is a simple method. You can see that we break it into two summers as it is single, and yeah, you can see that. Moving towards the case 5. we rarely done this thing that we move takeoff point to the opposite to the summer or in the flow of direction. So we rarely do this. In block diagram reduction technique, we don't do this because it will make the block diagram complex. So we can see that if you want to move a takeoff point after a summer, in the direction of flow, you have to multiply with the summer with the opposite polarity. As you can see that here the polarity of the summer is positive, and if you want to move the gain in the direction of flow, you have to multiply with the negative polarity. Okay. Moving to the next case, as you if you want to move a gain in the opposite direction, uh, before the summer, so you have to divide, you have to divide you have to multiply with the same polarity. Moving to the slide, here you can see that you have to move the same polarity, you have to multiply with the same polarity summer. And in case 7 8, the gain connected in parallel, if gain connected in parallel, it is just simply add. Okay, if gain connected in cascade, it will multiply it. These are the some basic rule to reduce the block diagram. And the latter part of the video and we will have some numerical based on this. Okay, so that's it for today, guys.